Hello everybody, I'm Diana, I'm the coach of the team Sportklinik alone, as you can see here. Juan is our project leader, Professor Höher and Jasper are our customers, and written there in pink you can see our 6 amazing developers which are going to show everything we worked on so far, starting with a short trailer.
The Lachman test is a measurement done by doctors to determine the laxity and the healthiness of the knee. In this clip, you can see how a doctor is performing a Lachman test while he's moving up the tibia of the patient. He's using an instrument. This instrument is called the rollimeter. Rollimeters are our problem. They are really costly, they are uncomfortable to use and not really reliable. So there's where our app comes in hand. We developed an app that uses the camera and the accelerometer sensor to determine the translation of the knee. And more specifically, we have an app that detects the knee injuries and the progress of the patients to improve the usability of the doctors. So now Jamal will talk about the models.
So, thank you, Nicolas. Analyzing our problem, we'll have a doctor that performs the Lachman test on a patient. Then a report is created to track our progress from the requirements. A report also consists of at least 2 measurements, since you need 2 measurements, one of the healthy knee and one of the injured knee, since the comparison is important and not only the raw values. We're using the strategy pattern here, since we came up with 2 solution concepts. One solution takes in the acceleration sensors of the iPhone, the other one takes advantage of augmented reality. Now I'm going to hand over to Ali to talk more in depth about the augmented reality solution.
Thank you, Jamal. So let's take a look. So how the SEL measurement works is that the doctor puts 2 markers on the leg of the patient and then uses our app to do the Lachman test and take a measurement using augmented reality. So if we take a deeper look, we will see that on the leg we have the patella and the tibia. Those are 2 very hard parts of the leg, and those are perfect to put the markers on. Reason for that being is that there's very little skin movement there, and that is great to take an accurate measurement. So when doing the Lachman test, what we actually care about is the distance here. And the distance between the starting point of the starting position of the red marker and the ending position of the red marker is what we care about. And we're using the cosine rule to calculate that using the blue marker as a reference point. Now moving into the marker design, we started with this here, but realized that we need different colors that the doctor knows which marker to put where. We also increased the contrast of the black marker, of the blue marker, to make sure that recognition works even in low light conditions. And finally, we added a white border because we realized that recognition is not that great on dark skin or if someone's wearing black leggings or something like that. So now Angelina will tell you more about the accelerometer measurement.
Thank you, Ali. So another technique we developed to quantify the Lachman test is using an iPhone motion sensor. The main benefit of this approach is that the doctor can take the measurement by himself only using an iPhone. The problem is, however, that the obtained data looks quite messy and noisy. But we have discovered that the slope of net acceleration describes the behavior of the knee motion exactly the way we need it to. For example, if the knee is injured, then the laxity of the soft tissue surrounding the knee joint is increased, which results in a soft and mushy endpoint. But if the knee is healthy, we have a firm endpoint. And if you look on those graphs, you can see that the slope of the injured knee looks much softer than the slope of the healthy one. Another discussion point we had is, how is the doctor supposed to hold the iPhone? Well, the side and top of the tibia are very good candidates for that, since there is no soft tissue to affect the data, and those positions are quite comfortable for the doctor. But actually, our implementation is completely independent of the iPhone orientation and iPhone position. Finally, we have discussed what's actually the most convenient and the most intuitive way to trigger the start of the measurement. And we have had a lot of ideas such as volume button, voice control, touch screen, but at the end we have come up with a motion detection idea, meaning the measurement is started automatically once the motion is detected. This approach is very convenient for the doctors since they don't have to press any buttons or do anything else except the Lachman test itself. And further, Eric will show you a short demo of our approach.
Thank you very much, Annalena. Before we dive into the demo, I actually would like to mention that we're showing you now real patient data, which we acquired during our trip to Cologne, using the augmented reality approach. So as the doctor opens the app here, he finds a list of all his patients. And if we dive into Maria here, for example, we see her information, and below that, a list of all the reports the doctor has taken with her. So far, we only have one report, but let's see this in detail. So first of all, we see all the metadata of the report here. And below that, on the left side, we see the mean on the left leg of all the measurements. Then the same for the right leg, and this one is the injured one. And on the right side, we see the result computed as the difference of both means. And we see it as absolute value here and as the relative value here. Below that, we see the deviation of the measurements in both knees, in millimeters actually. And here the deviation is quite low, but a high deviation here would indicate that a few measurements went wrong, or the doctor used different forces to compute the test, which makes him repeating them probably. So as we compare the data here in the app with the data we acquired with the rollometer, you see that our app is already quite accurate and works quite well. So thank you very much, and I hand over to Antonio now for our further roadmap.
Thank you, Eric. So you've now seen the current state of our app, and we think that our app is at a great stage already, but there are some cool improvements we still want to make in future. So let's talk about them. I'll jump right into it. I'll first talk about the augmented reality strategy. So we want to improve the accuracy of, with a mathematical model that would then filter out the 2 of the 3 directions we have when collecting the data, and only use the direction that we actually need for the data. Another approach, like Ali told you, there are areas on the knee with a lot of skin movement. So we want to find the perfect position where to put the markers so we have less noise in our data. One approach would be, for example, putting it on the side of the leg, which would actually also fix our next problem, which is single person usage with the augmented reality strategy. So for now, the doctor needs an assistant to hold the phone, and we want to get rid of that need. So in future, we hope to put the iPhone on a chair and do the measurements from there, or maybe to put it on the doctor's chest. He won't be able to see the display then, which is why we want to introduce acoustic feedback into our app, which we think would be an intuitive way to help the doctor do the measurements. Let's now talk about the accelerometer. We again want to improve the accuracy of our model by studying some machine learning algorithms that would help us filter out the actual important data and filter out the filter to the actual important data and filter out the noise. Secondly, we want to improve usability by introducing a measure unit. The raw accelerometer values are quite hard to interpret, so we think a measure unit, for example, 0 to 100%, would be a lot easier to interpret and probably would help also with comparison in between patients. Here again, the display is hidden away by the doctor's hand, so we also want to introduce acoustic feedback for the accelerometer. Last but not least, thank you for listening. Thanks to our customers for the great continuing support and the amazing trip to Cologne. And thanks to our partner Alyosha for providing us with valuable tools and insights. So we are open for questions now.
Presentation. I was actually supposed to ask a question and I forgot what I should ask. I'm proud of you, great work. So let me think about one question quickly. Do you think that one thing that you mentioned during this project is putting the marker on the hand of the doctor? Do you think using a reference marker on the hand of the doctor be a good place to would it work? Would it be robust enough?
You can.
Actually, yeah, we're thinking of that because during the test, the doctor is actually leaning on this hand and therefore fixes this position, so it could be a really good reference point for us. But we're trying that out and we'll see how the data will look like.
Thank you.